So I'll do a quick side quest now about like, how does this better code understanding usually work? And we already heard some examples of this, but I want to show you how there's actually different ways that tools out there are doing this. So because what you usually need is like the tool that you're using for this code understanding, which at the moment in a lot of cases is an IDE, that tool actually executes search queries, right? So it's basically like a search that happens here over a representation, some representation of the code base. And this representation can be done in different ways. So the first and simplest form, like almost a little bit of a naive approach, is that of actually the tool is taking the abstract syntax tree and the file tree and the pure text of the code and turning that into search queries and results. So on this slide here, it says abstract syntax tree, but the screenshot is actually not quite representative of this. I think the screenshot shows more like a text search over files, right? But this is an example from an open source coding assistant called Klein that is taking this kind of like more straightforward, direct approach using abstract syntax tree and simple text searches. This actually, even though naive, works surprisingly well. So we have some teams using this coding assistant who are very happy with it. The downside of this approach is that it usually leads to still quite a lot of code and text being sent to the large language model, which uses up tokens quite quickly. Another approach, and this is the more classic retrieval augmented generation approach, is using vectors or embeddings and vectorizing the code base, right? So here you have an example from GitHub Copilot that is a bit more specific about picking out certain parts of the code that might be relevant to my question. So you can see here, there are actually snippets of like a few lines of code in different parts of a code file instead of like sending the whole file to a model. So this is quite a common approach. Here's another example, actually, again, from Cursor, where you can see, so I'm asking a question here, like, can you see any tests for the repository choice box? And you see it's kind of breaking it down for me into a search query that is not only taking what I'm typing right now, but also taking some context from previous parts of the conversation. And then again, just finding relevant snippets for my problem. Yet another way to do it is, and I think we might have seen like a small example of that in John's talk just now as well, is to combine your IDE coding assistant with code search. And I think SourceGraph and their coding assistant Cody is a really good example, because SourceGraph, even before the AI hype, was already quite a good code search product, right? And now they've combined their coding assistant with their code search to do this context orchestration. And they've even found, I think they've even dropped, using vectors and embeddings, because they found that the combination with the code search was already so useful that they actually dropped that part for now. And then finally, like the maybe like most sophisticated version of this, and also what we used in the COBOL example that I gave before, is to create a full knowledge graph out of your code base and also enrich that knowledge graph with additional information. For example, with documentation that you have, or let me see, I think I have it here on the next slide as an example. Yeah. So in this case, so I don't know if you can read it, but this is like a Java code base. This is actually an open source medical record system Java code base, also relatively old and messy. And so for each of the classes and methods here, when the knowledge graph gets created, it gets enriched with large language model summaries of each of those nodes, so that you already have like functional descriptions and stuff like that in the knowledge graph. And you can even like enhance that by saying, during creation of this knowledge graph, also large language model, please try to determine which parts of the code base belong to which business capabilities. And that can maybe give you insights into like which parts of what business capabilities you have, which parts of your code base might belong where, how you can potentially break it apart in a monolith to microservices effort or something like that. And finally, another example of this knowledge graph approach is there's one example here of a product called Unblocked that actually creates a knowledge graph out of your code bases, your Jira tickets, your Confluence pages, your pull requests, your Slack discussions. So you can do multiple integrations, and it puts it all into one big knowledge graph. And tries then to, like, based on your intent and your situation as a user, to determine, is somebody looking for, on a Confluence page, you might have coding conventions, and on another page, you have a product vision, which are very different things, right? So in a knowledge graph, you have opportunities to actually, like, categorize things as well, and not just treat them all as Confluence pages. That makes sense. So to just, like, wrap up this little side quest about how this works. So the key in all of this is this code-based representation, right? And that is actually a search problem. That is not an AI problem, right? You could see by those different examples that it's not always about vectors and embeddings, which is kind of the default thing that people talk about in retrieval augmented generation, but it can be all kinds of other code search, code navigation approaches that we already have.